Have you ever wondered what could be hiding inside a mysterious crater in Madagascar? Imagine a landscape marked by the enigmatic imprint of a colossal crater nestled in the heart of Madagascar. This isn't your average dent in the ground. This massive formation stretches hundreds of miles across, a silent testament to an event of astronomical proportions. What could have caused such a gargantuan scar on the Earth's surface? Scientists have been scratching their heads, poring over data and examining the area with a fine-tooth comb. Some believe it to be the result of an asteroid impact, a cosmic collision that happened hundreds of millions of years ago. Others point to geological processes and tectonic shifts. But what makes this crater a point of interest for geologists isn't just its size or the theories surrounding its formation. It's also its location. Madagascar, an island off the southeast coast of Africa, is a geological wonderland. Its geology is diverse, with Precambrian rocks dominating the eastern center, intruded by basalts and rhyolites. The west consists of sedimentary rocks, while Archean rocks are found in the northeast and south. This geological diversity could hold the key to unlocking the secrets of the crater. Could the impact that created this crater have triggered a mass extinction event? Could it have led to the creation of the unique geological features we see in Madagascar today? These are the questions that have been keeping geologists up at night. But the crater isn't giving up its secrets easily. To confirm their theories, scientists plan to drill into the structure for physical evidence of shock. It's a daunting task, but one that could potentially rewrite our understanding of the Earth's history. As we delve deeper into this intriguing crater, prepare to uncover the hidden secrets beneath its surface. The journey into the heart of the crater is just beginning. What revelations lie buried beneath the ground? Only time will tell. But one thing's for sure. The answers we find in this mysterious crater in Madagascar will undoubtedly shed new light on our planet's past. What does the unique geology of Madagascar tell us about this mysterious crater? Well, let's dig in. Madagascar isn't just an island of lemurs and baobab trees, it's a geological treasure trove. From the east to the center of the island, we find rocks that are as old as time itself, Precambrian rocks that formed over 1 billion years ago. These ancient stones, weathered by eons of natural processes, might hold clues to the origins of our enigmatic crater. But the geological diversity doesn't stop there. Intruding upon the Precambrian landscape, we encounter basalts and rhyolites, igneous rocks born from the fiery belly of the Earth. Basalts, dark and dense, are a testament to volcanic activity, while rhyolites, with their high silica content, hint at explosive eruptions. Could such violent geological events have played a role in the formation of the crater? In the west, we find a different story. This part of the island is dominated by sedimentary rocks, layers upon layers of compacted ancient debris. These rocks are like a history book, each layer representing a different chapter in Madagascar's geological past. Studying these layers might reveal whether the crater was formed by a sudden cataclysmic event or a slow and steady process. And let's not forget about the Archean rocks in the northeast and south of the island. These are some of the oldest rocks on Earth, dating back to over 2.5 billion years ago. Their presence could suggest that the crater is much older than we think. Finally, we have the metamorphic rocks, transformed by heat and pressure into new forms. These rocks, bearing the scars of the Earth's tumultuous history, might provide insight into the forces that shaped the crater. So what do all these different types of rocks tell us about the crater? Each one provides a piece of the puzzle, a hint to the crater's history and formation. By studying them, we're not just examining stones, but reading the pages of a geological diary written over billions of years. These geological clues may just be the key to uncovering the crater's mysteries. What secrets does the mysterious crater hold, and how do we uncover them? To unravel the enigma of the crater, we employ a variety of exploration methods. One of the most effective is drilling. By penetrating the Earth's crust, we can retrieve rock samples that have lain undisturbed for millions, possibly billions of years. These geological time capsules offer invaluable insights into the crater's past. They reveal the intensity of the impact, the size of the asteroid, and even when the event occurred, Yet drilling is just one piece of the puzzle. Complementing this, we use ground-penetrating radar, a non-invasive method that allows us to visualize the subsurface. This technology bounces radio waves off underground features, creating an image of what lies beneath. It's a bit like taking an X-ray of the Earth. So what have these exploration methods unveiled about our crater? Well, the rock samples recovered from the drilling operations have been intriguing. They display signs of extreme shock metamorphism, a transformation that occurs when rocks are subjected to the immense pressures of an asteroid impact. This confirms our suspicions that an astronomical collision was indeed the architect of this vast depression. Additionally, the radar images have disclosed a series of radial faults, patterns of cracks emanating from the crater's center. These are typical of large impact structures and provide further evidence of an asteroid strike. Furthermore, the radar has detected magnetic anomalies, areas where the Earth's magnetic field is unusually strong or weak. These anomalies suggest that the asteroid was rich in iron, a metal that can significantly alter the local magnetic field. Despite these findings, the story of the crater's formation and history is far from complete. Each piece of evidence leads to new questions and fuels further exploration. It's a complex jigsaw puzzle, and although many pieces are still missing, the picture is slowly starting to take shape. Each new discovery brings us one step closer to solving the mystery of the crater. How does this crater compare to other similar geological features around the world? As we venture further into the realm of craters and impact sites, it's worth drawing some comparisons to deepen our understanding. Let's start with the Redefort crater in South Africa, considered one of the largest verified impact craters on Earth. With a radius of nearly 125 miles, it's a significant geological feature. However, the potential site discovered in New South Wales, Australia, could dwarf it, spanning up to 300 miles in diameter. The Australian site, believed to have been formed hundreds of millions of years ago, shows signs such as radial faults and magnetic anomalies, similar to what we see in Madagascar. These signs are like breadcrumbs left behind by the universe, guiding us to the history of these massive structures. Then there's the infamous Chicxulub crater, associated with the extinction of the dinosaurs. This impact site in Mexico is about 120 miles in diameter, and its discovery has been instrumental in understanding the catastrophic events that led to the end of the dinosaur era. Could the crater in Madagascar hold similar secrets about the Earth's past? Comparisons with these sites could provide valuable insights into the formation and history of the Madagascar crater. The similarities and differences between these geological features can give us clues about the forces that shaped them. For instance, the age of the craters may hint at the period when the impacts occurred. The size and depth of the craters can give us an idea of the size and speed of the asteroids that created them. And the geological features in and around the craters can tell us about the environmental conditions at the time of impact. Even the location of these craters can provide insights. For example, the Australian site likely occurred when the continent was part of the supercontinent Gondwana. This raises questions about the location of Madagascar during the formation of its crater. Although comparisons offer some guidance, the Madagascar crater holds its own unique secrets waiting to be discovered. The journey to uncover these secrets is a fascinating one, filled with mystery, discovery, and a deep appreciation for the forces that have shaped our planet. So, what have we discovered on this journey into the heart of the mysterious crater? Well, dear listener, we have unearthed a wealth of geological secrets, each a piece in an intricate puzzle that paints a fascinating picture of our planet's past. We've explored the unique geological features of this vast crater, from the radial faults to the magnetic anomalies, each hinting at the violent cosmic impact that may have occurred hundreds of millions of years ago. We've bore witness to the layers of Precambrian rocks, the basalts and rhyolites that dominate the terrain, each layer a testament to the eons that have passed. And within these ancient stones we've found evidence of Madagascar's rich mineral wealth, a treasure trove of gemstones and graphite, a testament to the island's vibrant geological history. We've also delved into the realm of speculation, drawing comparisons with other impact sites around the world. We've speculated on the possible connection to the supercontinent Gondwana and considered the potential role this impact could have played in triggering mass extinction events, forever altering the course of life on Earth. But perhaps most importantly, we've learned that this crater, like so many other geological phenomena, is a testament to the dynamic, ever-changing nature of our planet. It's a stark reminder of the cosmic forces that shape our world, forces that continue to mold the Earth's crust and stir the cauldron of life. And yet, despite all we've learned, we are left with more questions than answers. What other secrets does this crater hold? What can it teach us about our planet's past? And what might it tell us about our future? These are questions that will undoubtedly fuel further exploration and discovery. As our journey concludes, we leave with more knowledge but also more questions, a testament to the enduring mystery of the Madagascar crater.